Hi everyone, C+ Guy here, and today we're going to be talking about the scope resolution operator. Now when I first saw this double colon, I'm like, what the heck is this thing? And did some research, and it's called the scope resolution operator. This is going to be a first in a series. I don't know how many videos I'll do. The scope resolution operator can be used in many different contexts, but in C++ it's a very essential tool. The scope resolution operator in C++ allows you to access or disambiguate identifiers across various contexts. It's simple to use, but incredibly versatile, making it a fundamental part of C++ programming. Well, I just read that out of a book, but it's accurate. So I'm going to go through the video. I'm going to go through 4 different cases of the scope resolution operator. First one is when you access namespace members, which is very handy if you're coming from C. The other one is when you do enumerators. Very, very helpful enumerators. And as you're typing your code, the IntelliSense, you'll actually look up values in your enumerator. Another use for the scope resolution operator is when you create a class, your class can have member functions in it. You can actually define or do your function definition inside the class itself. But that can get quite crowded, get quite ugly. So one of the things you can do is create a separate definitions file, kind of like what you do with C, where you have a header file and you have a C file where the function definitions are. You do the same thing in C++, and the scope resolution operator will help you do that. I will show you how to do that. And finally, when you're dealing with legacy C code and now you're introducing C++ classes, you're going to run into a situation where, like, hey, I have the same name that was it's in some C file somewhere in some C library, but I also have the same name in my class, and they're conflicting. And the compiler's like, I don't know what to do. It's barking at you. It's like, you've got the same name for, I don't know which one to use. And this is where the scope resolution operator also helps, and I'll show that as well. So I'll break each one down, so sit back and relax. So starting with a clean slate here, this is a C++ project. The toolchain editor is set to main GWGC, and I left everything as defaults. At the beginning of our project, we have no variables, we have no functions defined other than main. But one of the things I want to point out is, probably many of you are aware, but outside of main, anything defined up here is what we call global space. And in C++, knowing when someone says the word global space, and it may be a misnomer, it really means, in terms of the scope resolution operator, that it's blank. So for an example, I'll create a function in global space. Let's say we have a min function like this. Now in a C program, we would access it like any function. For example, like this. And of course it builds, we get some warnings, some initialization warnings. But for argument's sake, let's do this. Let's just look at this. Min is here, min is defined up here, and it does build. Now, what is not commonly known, this is one of the things I found out earlier, and it's a very effective tool, is I can start with my scope resolution operator, and I get a lookup list right here. And then notice that there is nothing here. There's no standard, there's no namespace name, it's blank. That's global space. I kind of wish they'd had a name for global space, but if you leave it blank, and you ever see this crazy notation of 2 colons in a row, a scope resolution operator with nothing in front of it, you're looking up stuff in the global space. So when I hit control space, these are all the functions available that you would typically see in C. That includes anything in a library, and we see a lot of the pthread functions, because this is written for Linux. But our function min is in here. If we actually start typing, here, wait. There it is right there. So we were able to look this up in global space. So keep this in mind. This is a handy little tool to narrow down something that you want to call a specific C function. Remember, C files will build in C++, but you want to call the C-type function that you have in a library, such as math.h or standard.io. You can look it up with this and use your IntelliSense. Pro tip right there. Okay, so now that I've added a function in global space. I'm going to do my first namespace, and I'm going to call it my constants b. And in here, I also have another function called min. Yeah, I know it does the same thing, but for example, this is just an example. And we threw some constants in here. And this is typically what you would use a namespace for, to isolate names of constants that have the same name. They have the same name as in another namespace, but you want to deconflict them. You don't want to make it ambiguous. So likewise, I could have another scope of constants right here. So we have my constants A and my constants B. And if you look, there's something interesting going on in here. They're all the same name. Okay, Max XL is listed in both. Now in C, this would blow up if you tried to build this, because it's the same. I mean, the variable has the same name. And then in C, what you would do is you would have to come up with unique names for whatever header file you were using these in. Another thing I want you to notice is I'm not using the pound define macro. Now, pound define macros is just really a global text replacement that is done by the preprocessor before you start compiling your program. The best practice way today, or probably for a while now actually, is to not use pound defines for constants like this, to actually make them types. For one thing, you cannot put pound defines inside of a namespace. For example, I cannot go pound define here and then also do the same in this namespace. They won't deconflict. If I use some constant somewhere else, it's not going to know that it's inside of this or this namespace. For example, now you notice it does build, but you get like kind of an ominous warning where some constant has been redefined. And this has actually bit me in the ass pretty hard. I thought when I first started really trying to leverage namespaces, I thought it was pretty handy. I had pound defines in separate namespaces like this with the same name. And it built. I'm like, oh, it built. It's going to work. No, it's going to grab. I don't know if it grabs the first one and keeps it or the second one. And you just get a warning. And if it's spread across multiple files, it's very hard to find the problem. So this does build, and it looks like, okay, I started the debugger, and we start at main. If I step over this, N is 2. So it went with the second one. So if you have this pound define, you have this macro defined in multiple places, it's going to go with the last one it reads. But all you get is this ominous warning. And you could actually build this. This is one of the complaints I've had about this. But it's an easy remedy. Don't use pound defines for constants. Just don't do it. All right, back to where we were. So now that we have two namespaces, I will show you how they can be used. So what I did next was I created two constant float variables, and I initialized them from the constants in the two separate namespaces. And if you notice here, there's your scope resolution operator. Now I put this in front of it, and I'm saying, hey, go to the namespace and use this, and it uses that up here. Likewise, for the namespace I defined as B, I grab this value, and they both have the same name. Now this comes in quite handy if you have a lot of low-level C-type code, but if you use the C++ compiler, now you can use the same names. You don't have to refactor. You have to do a lot of crazy refactoring to use different names for your variables to define different constants and stuff like that. I thought this was pretty helpful for me, and I will run it. As we step through the code, we see that F1 is defined as it should be, 127.3 for A, and for the next one, 278. And we'll just go through the last line here. And the final output is exactly what we would expect with we're using the appropriate values in the namespaces. And if we wanted to, we could call these functions from inside the namespaces separately and use the same name. For example, I'll give you, like I showed earlier, I can do the global namespace, or if I want to run, I can run min. Yeah, I realize it's an integer, but you get the point. And likewise with the other namespace, same thing. So I think that the takeaway with namespaces is, if you have like legacy C code and you don't want to write a class to incorporate functions, you can just wrap them in a namespace. I mean, all it is, you take your stuff basically and put 2 brackets around it and use the namespace keyword, and now you've got a namespace in that, and then you can access it just like this. So you're kind of using it, it's a form of polymorphism, and you can use object-oriented programming techniques and do things like this. You know, where min would be a method of this namespace. You know, the purpose of this channel is to show how you can leverage the power of C++ if you're a C coder. You want to, that's the environment you want, that's great, and you want to start using C++. This namespace method is a powerful tool. It can be used in a lot of different ways. You can take these namespaces and divide your architecture into different areas. Maybe you have different drivers, for example, driver A, driver B, driver C, and they all have a lot of the same names inside of them, like initialize or run or get address, stuff like that. You can use the same names, and you just qualify them with a namespace in front of them, and that's it for this example. So I'm gonna be right back. I will see you in a few. All right, this is going to be a short example. I'm going to use enumerators, how the namespaces can be helpful for you. Let's start with a couple of namespaces again, and I will show you the code. Again, here I have 2 variable names called fruit and color, and they are both they both have the same name, and just like before, you can do a lookup and like that. Similarly, I can do a lookup as I'm typing along. You can see where in C this might be handy, where you have a similar name across multiple files and you don't want to refactor. So we throw a namespace around it, problem solved. It's no longer ambiguous for the compiler when it builds. So quickly we will run this. One thing I noticed about Ming W is that you actually have to run it to completion to get the output, and you'll see that those are the right answers. The takeaway is, of enumerators with the same name, you just wrap it with a name like this and you put brackets around it. Now you can reuse it in different places, and then you can qualify it with different names. The scope resolution operator will allow you to do a lookup, which speeds development time. So there we go. I will see you on the next one. I'm going to take a quick break. Okay, so in this example, we're going to go over how scope resolution operator can be used to do function definitions outside of a class. One of the things I learned early on when I first started working with C++ is you can actually put code in the header. I was like, who puts code in a header? And one of the colleagues I worked with was like, here, look at this. Pulls up the header, and I was like, holy cow, there's code in here. So what I did is I created a little test class here. Call it my class. There's your function declarations. There's no code. And then I put a function in there, and then I defined it. And this is perfectly legal to do in C++. And for small classes, or maybe you want to do it for certain function definitions, this is the standard template library is written this way. The code is inside the class itself. But in general practice, if you have a class with a lot of member functions in it, it gets to be difficult to read and difficult to maintain. So what you want to do is you want to keep your declarations in one file, a header file, and then keep your definitions in another file, the CPP file. So just like in C, you have the pair. You have the C file, header file pairs all the way down the line, which is a great best practice. So in reality, you would do this. Let's say you wanted to move it to the definition file, you would do it this way. I would do this, and then when I go to, I already had it in here, I'll uncomment it. So now print value is in the definition file, and this is where the scope resolution operator comes into play. You have to put this in front of your name on all of them. So if you look, each one of these are just declarations here, has a corresponding definition, the scope resolution, you know, in front of it. And of course it will build. Now for my first example, and I'll show you how this works in reality. It doesn't know my class, so I'm getting an error. All you have to do is include the header file. So I can instantiate it this way, and now I access those member functions just like anything else. I can set m value like this manually. Oh, no, I can't. It's private. Yep, it won't build. So they have a setter function that does this. And like that. And you can also do function calls the same way. And that'll print the value, so that will build. No, it doesn't build. It doesn't build because there is no default constructor. You have to pass a value in when you instantiate it. All right, we won't. This isn't a C++ video, but I will show you how this gets fixed. You have to give it a value when you create it. That's why. So now it works. If I run it, I continue to the end. The value is 2. So we started out with 123. We set it to 2, and then I printed it out. So this is an example of why you would use the scope resolution operator in a class environment. The scope resolution operator has so many different uses. You know, we mostly think of it as in namespaces. So I wanted to show you in this example where this is where the name scope resolution applies, because we want the scope of this class, and we want these functions to be defined in terms of the scope of this class. It's not really a namespace. Now, one of the things you could do if you wanted to get really creative, I could put this whole class inside of a namespace. And it's quite easy to do. You just have to remember to put everything in the brackets. And I can give it any name I want. You know, I could call it test space or something like that. It's not going to build yet, because not only do I have to do it in the header, I have to do it in the source file. Like that. And you could always put little notes like end of namespace here. If you have a long file and you're looking at this dangling curly brace, you're like, what the heck is that for? And now you know. So, of course, it doesn't build, and I'll show you why. It doesn't know what, this is not in global space. That's kind of implied. So you have to put, this is where autocomplete's your friend. I have to do this. And now it builds. And let's say you can have a class of the same name, but if you put it in a different namespace, now you don't have to refactor it. So you could have a class called initialization or a class called default. I mean, there's a lot of common names we like to use as developers, but it conflicts because now you have it all over the place. It's like, well, wait a minute, that's for this, and that's, so now you can wrap it in a namespace. So it's quite handy. Let's say and this is my final lesson, and probably a lot of you know this, or maybe you saw this before and you're like, I don't understand why they do that, but I just do it anyway. If I don't want to have to use test namespace everywhere, or test space every time I do this, I can do this little trick like this. Now I can get rid of this. Now it builds. So my recommendation is, if you want to do this, and you're going to see this come up with the namespace standard, or STD, which has a lot of cool stuff in it. You're going to want to use the word using namespace STD. Like, I could throw this at the top of the file, right? And forever through the end of this file, it's going to assume that this is coming from the test space namespace. But that's not really a good coding practice. I've seen it at the top of source files, and it's okay. You never want to put it in a header file. Keep the using namespace keyword at the function level, and it'll remain in that scope. That way it doesn't affect the rest of your file. And with that, that's my last example. I hope you enjoyed this video. You got something out of it. I'm probably going to cover more namespaces, and probably has to do more with the STL library. And for now, I thank you. If you like, if you like what you hear, give me a like and a subscribe. It'd be great. I'm doing this kind of as a hobby, and I would like to continue doing it. Try to spread knowledge out there. So thanks again, and I will see you on the next one.